into section 4. And we're going to show you something that's kind of cool. And then we're going to look at just a few problems in this section. It won't take us very long. So here's a simple question for you. Does this look familiar to any of you? It is a triangle, no question about that. Is anybody familiar with this triangle? Does anybody know how I'm going to figure out what the next row of the triangle is? I'll give you a hint. It starts with a 1. Okay, 5 is next. Anybody know what's next? No, that's a good try, but it's not 9. 10 is correct. I think that 10 came from K row. So let's go back to K row. K row, what's going here? Did you say another 10? Okay. Then what's going here? Okay. Then a 1. Now, are you guessing or are you using a method to figure those out?
For the last one, I didn't use a method. So 1, 2, 3, 4, 5. The other one was probably just random guess.
Okay, so you guessed that that was going to be 10 and you just happened to be right.
Simple addition, isn't it? You can take simple addition.
Simple addition. What are you thinking, James?
Well, 1 times itself, or 1 times 0, since it has nothing else, will give you 1 on both sides. Well, in the middle, 1 plus 0 is 1. In the middle, on the second line, 1 plus 1 is 2. 1 plus 0 is 1. 1 plus 0 is 1, and so on and so forth as you go down. So between the two 10s, it'd be 10 plus 10 is 20. 5 plus 10 is 15. 5 plus 1 is 6, and then 1, and then copy it on the other side.
He is exactly right, ladies and gentlemen. But you probably didn't follow him unless you were familiar with how this works. Okay? Here's what he's saying. Correct me if I'm wrong, James. He's saying, just bring the 1 down. And to get the next entry, just add the 2 entries above it.
Yes.
1 and 5 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And put a 1. So main campus, what would the next row after that be like? I'll start you with a 1. 7, then what? 21, then what? 35, then what? Then what? Then what? I'll do the last one. It's 1. So that triangle is called Pascal's triangle. If you study very much mathematics, you'll run across the name Pascal a lot. He made many contributions to the study of mathematics. I wonder why we're looking at this in this chapter. Well, something really cool is going to happen here in a few minutes. Let's call this top row row 0, the next row row 1, then row 2, then row 3, 4, 5, 6, and 7. And by the way, you can extend Pascal's triangle as long as you want to. You don't have to hold it to just 7 rows. You can do a whole bunch more. Tone that down even more. Let's bring it back up just a hair. Okay, and not only that, but in each row, let's number each entry. Okay, so this is, I've got to think about this a minute. Yes, this is entry 0, 1, 2, 3, and 4. So the first row is row 0, and the first entry in each row is entry 0. Okay? So if I told you to go to the 5th row, the 3rd entry, what number are you looking at? I'm looking at a 10. That's right. I'm looking at this 10 right here. Entry 0, entry 1, 2, 3. Okay. If we said to go to the 7th row, 4th entry, 0, 1, 2, 3, 4, it'd be 35. Let's do one more. You guys decide which row and which entry. Which row do you want, Amy?
6.
Okay. Oh, fiddlesticks. 6th row. Entry what, Dustin?
4.
4th entry. 6th row, 0, 1, 2, 3, 4. It'd be 15.
So you actually count the 0, right?
Say that again.
Like normally we don't like just say like 0, 1, 2, 3, 4 when we're counting, but when we're counting over we have to say like 0.
Yes. You won't get the right entry unless you do. Now, watch this. Main campus. I would like for you to figure a combination of 6 things 4 at a time. Anna, I would like for you to figure a combination of 5 things 3 at a time. Metro and K-Row, I'd like for you to figure a combination of 7 things taken 4 at a time. Guys, Holden doesn't have his calculator out. I'm telling. You're not using it.
Aha.
Huh.
Tricky, tough deal.
Main campus, what'd you get for a combination of 6 things 4 at a time? Really? Seriously? You got 15? That's pretty get down funky jive, isn't it? Hey, Anna, what'd you guys get for a combination of 5 things 3 at a time? 10? Really? That's get down funky jive. Metro and K-Row, what'd you get for a combination of 7 things 4 at a time?
35.
Let's get down funky jive. What are we saying here? We're saying that the entries of Pascal's triangle are really just combinations. So if you want to find combinations, you can just use Pascal's triangle if you really get a wild hankering to. Now, you know what we're going to use this for? Absolutely nothing. It's just kind of neat. It's just kind of fun. If you want to know what we're really going to do at this section, flip over to page 560. Mr. Black, that was kind of cool. Yeah, I know. I know, Matthew's kind of cool a lot of times. I want us to look at number 9 in your exercises together. And what's going to happen here is we are going to have a problem that asks us how many, and we're going to use not a combination, it's a bad word to use. We're going to use a compilation of strategies. We're going to use two strategies together to figure it out. Let me show you what I mean. A committee of 4 congressmen will be selected from a group of 7 Democrats and 3 Republicans. Find the number of ways of obtaining each result. And number 9 says 1 Democrat.
Exactly.
Okay, so again, what's happening here? We're making a committee, and there's going to be 4 people on the committee, and we're choosing from 7 Democrats, and we're choosing from 3 Republicans. Now, so how are we going to go about this problem? Well, we got the big picture, and then we got the nuts and the bolts. The big picture is this. What we're going to do is take the number of ways that we could pick the Democrats and multiply that by the number of ways we could pick the Republicans. So the big picture is we're drawing blanks. Okay, and that'll give us the total number of ways that the committee could be chosen. So that's the big picture. Now, let's take each part of this now. Let's take the number of ways the Democrats could occur. Okay, so let's think about that for a minute. Now let's ask, is repetition allowed? Am I going to choose the same person for more than one spot? No. Does order matter? On a committee, does order matter?
No.
No. So to pick the number of Democrats, I could use a combination. I'm picking from 7, and I'm picking 1. All right, now let's think about the number of ways I could pick the Republicans. Well, using the same logic, order doesn't matter there either, and repetition is not allowed. So I could use another combination. How many am I choosing from? 3. And how many Republicans would I have to choose?
3.
3 of them. Why 3?
Because there's only 3 of them out of a 4-seat committee.
There's 4 seats on the committee, that's right. And one of them's going to be a Democrat, so 3 more have to be Republicans. So for number 9, I could use a combination of 7 things 1 at a time times a combination of 3 things 3 at a time. Now, you can figure that out later. Number 10 is the exact same problem, except this time they say we're going to have 2 Democrats. Okay, but our thinking is going to remain the same. So I'm going to take the number of Democrats times the number of Republicans. The logic all works the exact same way, except now with the Democrats, I've got a combination I'm picking from 7, and now I'm picking 2. And with the Republicans, I got a combination I'm picking from 3. But again, since I've only got 4 members on the committee, I'm only picking 2. So for number 10, it'd be a combination of 7 things 2 at a time times a combination of 3 things 2 at a time. And you guys can figure out what that's equal to. Okay. The last thing I want to look at is a problem like number 13, which is really a cool problem. So I need to make sure everybody's moved on from numbers 9 and 10 and are ready for number 13. Here we go. Suppose 8 fair coins are tossed. Find the number of ways of obtaining each result. And number 13 says exactly 3 heads. Not less, not more, exactly 3. So let me think through this problem for you, and then the next one you should be able to think through yourself. So look, here are my 8. I'm going to put numbers down here that represent my 8 tosses of the coin. Toss 1, toss 2, toss 3, 4, 5, 6, 7, and 8. Now each one of those 8 could show up heads or tails, right? Okay. But I'm looking for the number of ways that I could get exactly 3 heads. Well, that's going to be a bunch. I mean, let's think about it. One way I could get exactly 3 heads is if the first 3 tosses were head and the rest of them are all tails. In other words, tosses 1, 2, and 3 would be heads. Or I could get heads on the first 2 and then heads on the 4th, and the rest of those could be tails. That'd be a case where 1, 2, and 4 would be the option. Or, I mean, any 3 of these numbers that are paired together, like if I tossed a head on 3, and say tossed a head on 5, and then say tossed a head on 8, and everything else was tails, that would be exactly 3 heads, which in this case would be like getting heads on 3, 5, and 8. Okay, so do you see that getting 3 heads is equivalent to picking 3 numbers out of those 8? It's equivalent to saying how many ways can I pick 3 of these numbers out of 8? And order wouldn't matter. Because if you get head on 1, 2, and 3, that's the same thing as getting heads on 1, 3, and 2, right? It's the same result. And repetition's not allowed because you're not going to get a head on the same toss more than once. You can't have 1, 1, 3. That doesn't make any sense. So what have we said here? Repetition's not allowed. Order doesn't matter. I'm picking from 8, and I'm picking 3. So that'd be a combination of 8 things 3 at a time. You could figure that out. Now, number 14 asks, how many ways could you get exactly 4 heads? So that'd be equivalent to picking 4 of these numbers out of 8. So in essence there, what we're doing is we're working an equivalent problem, a problem that's got the same answer. We're asking the question, how many ways could I pick those numbers out of 8, which is equivalent to saying how many ways could I get that number of heads. Okay, so your assignment for section 2, this is section 4, is simply page 560, problems 9 through 16, and we already got you a jump start on 9, 10, 13, and 14. That assignment should take you probably about 10 minutes at most.